So, hello, my name is Anders. I'm going to talk about mutation testing, theory and practice. I work at Traptima, like I said, which is a fintech company. We sort of minimize the risk in the entire financial system. We're the good guys in the fintech world. Yeah, so mutation testing, we're going to have a little agenda. What is mutation testing? How do we do it? How does it work? Prerequisites, workflow, whitelisting, what kind of mutations does mutmut do? This is my mutation tester, and a summary and maybe a live demo. We'll see where we are with time. So, something that happened for me was there's a lot of people saying coverage is not everything and it's worthless or something. And they were like, the solution is mutation testing. And I was like, I don't know what you're talking about. And they were saying weird things like if it succeeds, it fails. And it's just really hard to understand what they're saying. So I'm going to start by trying to explain mutation testing in a way that I think makes sense for me, that really made me sort of click what it is. So let's say you have a library. You built it from scratch. You've used it in a bunch of projects. You're using it in prod. You've got 100% test coverage, like really solid testing, you think. Yeah, and maybe you have 100% branch coverage even. You're like really, like this is solid. But what if I told you there's a different code base? That's not your code base and it passes all your tests. Right? That's not a good feeling. What's that? So it's very similar to your code base, but it's not your code base. Well, now what if I told you I have hundreds of them? That shouldn't make you feel very nice. So I have hundreds of them, and what if I switch them and you couldn't do git diff? Then you would be very nervous, right? So this is how I think about mutation testing. I'm generating these alternate sort of universe code bases, and I'm testing them, and the test part is to see if they still pass your tests. And if they do, that's a surviving mutant that's bad. So I'm going to go through, talk about mutmut, which is the mutation tester I wrote. And so when I wanted to do mutation testing, I wanted to try it out. I Googled it, and you find Cosmic Ray, which is the big name, still the big name. And I couldn't get it to install. I was hours into getting it to install, and I couldn't. So I thought, screw this, I'll refactor it. And I'm like, oh, there's thousands of lines of code. Never mind. And then there was another project, and I was 10 hours into refactoring that because the code base was way too complex. And I'm like, this is too hard. I'll just throw it out. I'll do it myself. Fuck it. Okay, so, and that's what I did. I just started from scratch. So let's start about saying, how does mutation testing work, right? So the name is a hint. We introduced mutations. So a mutation is a change to your code that should change your behavior, right? It's not we don't change doc strings or something. It's a change to the code that should change your behavior. And then we run your tests. And if they pass, when we change the behavior, something's wrong with your test. You have a hole in your test. You're not testing what you think you're testing. And even more scary, you might introduce an off by one error in the future, and you're not going to test it because you're not actually checking your boundary conditions. So let's think of the simplest mutation, which is just a comparison operator. If foo is less than bar, call buzz. But does your test suite break if I change it to this? Right? You've probably written some tests that wouldn't survive that. So this is mutation testing. We change the code in some nasty and subtle way the subtler, the nastier, the better for mutation testing purposes. So it's no longer running your code, it's running some your code-ish thing. So then what you have is what's called a surviving mutant. That's bad. The nomenclature is a bit difficult with mutation testing. Surviving mutant is bad. Killed mutant is good. Okay? Everybody's okay with that? So we do this kind of operation for every place where we have a mutation point, which is a place where we can change the behavior, like this. So probably you have something like 1 mutation point every other line on average. Some lines you'll have 10 because it's a really complex line. Some lines no mutation points. So how do you run it? Well, you just do mutmut run after a pip install. And you're going to get a little output. It's quite verbose because I'm trying to explain also what happens. So the emojis help. Saying killed mutant is good. Boo! Right? Because otherwise it's hard to know what's good and bad. So it's going to auto-detect where your code is, where you need to mutate the code. It's going to auto-detect where your tests are, so it knows if the tests are changed. And it's by default uses PyTest to run their test suite. You can configure that. So this is how we've tested our libraries at TriOptima. So now it's time to talk about speed, right? It's slow. It's really slow, right? Of course, because you're running your entire test suite for every mutation point. So you're changing less than to less than equal, then you run your entire test suite. You change, then you go to next point and the entire test suite, and on and on and on and on. So that's not great. So you can have hundreds and hundreds of mutants for even a fairly small library. So you probably don't want to run it in your CI environment. So there are some features in mutmut where I have to alleviate this. So if the code hasn't been changed since the last time you run it, I know and I don't recheck it. But if the tests have changed, the code is the same, I know that I can rerun the test suite only on the surviving mutants, only on the surviving mutants. So you have only 5 surviving mutants, I only run 5 times instead of 100. So that helps a lot. There's also features to run only on covered lines, because if it's uncovered, well, all the mutants are going to survive by definition. That works so. Right, if you have uncovered code, you probably should work on that first. You can also run the mutation tester on just 1 mutant to check it. So this cache where we keep track of the state of the code and the state of the test also works that if you control C out of it in the middle, it remembers where you were, so you can work on sort of partial results and then keep going from where you were and keep going, which is very nice. And it's also very hands-off. You can start it and come back the next day, and it's just gonna go. It's also gonna detect infinite loop if you insert an infinite loop and kill the process. Hopefully, right? So prerequisites. 100% test coverage is a soft prerequisite, right? It's not strictly necessary, but if you want to test some code and you really want it to be really solid, then you want 100% mutation score or killed mutations. You might want to try to get fairly close to 100% coverage first before you start. On the other hand, the really nice thing with mutation testing is when you get the list of the mutants, it's going to say, you need to fix this thing. And it's fairly obvious what you need to fix. So it's much nicer, like a workflow, just go through all the mutants from top to bottom and just fixing all the things. While coverage is a bit like, oh, I need something over here. It's a bit vague. So it can actually sort of feel better to work with. And in my experience, getting to 100% test coverage is the thing that will make you probably find the bugs, not mutation testing at the end. So you're going to get more bang for the buck for 100% test coverage than you're going to get for mutation testing. So, yeah, you should try it out. It's fairly easy to get started, and it can feel a lot more. It's nice. It sort of has a nice workflow to it. Yeah. So you have some mutants. What's next, right? So mutmut is based on this library Parso, which I really recommend everybody check out. It's an AST library for Python that's round-trippable. So you can read up your code as an AST. You can go in and change it and write it down, and it keeps your comments and your formatting and everything. So you can write refactoring tools with it, and super nice. This also means that my mutations, I can go in, make a mutation, and overwrite your existing code, and you only get the change, not destroying the entire code, which the other mutation testers, used to do. They've now changed to this. So you get a nice diff. You can just do a git diff and see what you changed. It's very nice. It's actually one of the major reasons I started writing mutmut from the beginning, because the existing mutation testers, they gave you a diff between like your code but mangled, and your code mangled with a mutation, and then a diff. And that was really hard to work with because it's not, the line numbers are off, and it's just terrible to find where in the code it changes. So next step, after you've collected your mutants, is either you apply it on disk, you write a test that fails, you revert your mutant, you rerun the test, say it succeeds, and you keep going. Or you can use mutmut directly to run. You can just look at the diff of the mutation and try to figure it out and run it that way. And the nice thing is mutmut updates the cache when it's going, so you're going to see your progress sort of move forward, and you don't have to rerun the entire thing because remember it's slow, so you do want to sort of incrementally work on it. So some mutants show real problems in your test suite. Like if you have a mutant like this, that's probably pretty bad. You should have checked that boundary condition exactly. But sometimes you want to whitelist things because the mutation tester will hit stuff and they are actually irrelevant. So let's look at some examples. You split on comma just once, and you take the first one, right? But you can mutate that 1 to 50. It doesn't matter. Right? It's just an optimization. So the mutation tester is going to go, well, what's this? And the answer is it's irrelevant, right? You should be using partition here anyway. But the problem is also whitelisting this is going to whitelist the entire line, which is not very nice because then it's going to miss if you screw up the comma and the 0 too, not just the 1. So whitelisting an entire line can be quite a big hammer to employ. So you should think about that when whitelisting stuff. This is the nasty one. Breaks, it's going to mutate to continue, which is brutal. So if you're going through a list and you're trying to find an item, you want to break out of it as soon as you're done. And if you just do continue, you're just going to keep going, and it's fine. There's no bug. It's just slow. Right? So you probably need to whitelist that. In the worst case scenario, you have an infinite loop. I do detect that and kill your process, but it's going to be slow. So you probably want to whitelist that just for performance reasons when rerunning the mutation testing. Then we have stuff like this, arbitrary strings. So you have a cache key, and you're using it just to set an attribute on your local object, and it just matters that it's the same in the function. So it can be anything. And I can mutate that string to whatever. It doesn't matter. So you need to whitelist those things. Wrappers, nobody cares. So the syntax to whitelist stuff is you do this, comment on the line, pragma no mutate, very similar to coverage, no cover. Mutmut has a simpler syntax. You have to write it on the same line. You can't write it on the block or the class, because whitelisting an entire class or a function for mutation purposes is just crazy. You don't do that. So what kind of mutations do we do? So it's going to modify literals, like strings, by inserting some crap in the middle and on the end and the beginning and the end of the string, literals. It's going to modify dicts. It's going to add 1 to all your integers. It's going to screw up your variable assignments. It's going to remove arguments to function calls. It's going to do a lot of crazy stuff. So here's an example straight from the source code. What it's gonna do with standard operators. So plus for minus, minus for plus. The nasty one is integer division, just normal division. Yeah, it's kind of brutal. But if you really care enough to use integer division, you probably should care that your tests check that it is integer division, right? Probably. So there's a bunch of these. Yeah. So yeah, summary. I'm going through this like, anyway. So mutation testing has made us a lot more confident in our test suite, like a lot more confidence in our test suite. Having a library with 100% mutation testing is really quite difficult. It takes a lot of time per line to achieve. And you're fairly certain that you've hit everything. It's very hard to introduce a new bug in existing code, because you test everything very thoroughly. And another thing that happens with mutation testing is it forces your code to be parsimonious. It forces your code to be just so. If you have some code that checks an if, and it does something, and it checks the same if, you're never gonna go through the mutation tester. It's gonna change one of those, and they're gonna be different, and your test will succeed, because, yeah, and it's just the logic. You can't make sort of okay code, but that isn't really, really nice past a mutation tester. So it's forcing you, weirdly, to write really, really nice, clean, exact code, which is very strange. And I've never heard anyone talk about it. I think a lot of people who talk about mutation testing on the internet have actually never used it. It's my strong intuition. You ask them like, oh yeah, okay, so mutation testing, you need that instead of coverage. Okay, sure. What have you done? And like 2 months later, I have no reply. All right. So I am hesitant. I've used it a lot, and I even wrote my own, right? But it has this weird side effect that we should really think about. That it makes your code really, really solid and nice, and it forces you to you can't explain to the mutation tester why that code exists if it doesn't need to exist, which is a really cool side effect. So, yeah, mutation testing, it's not a silver bullet, right? Like we had heard on property-based testing, right? You're not going to find all the bugs. Like I've had bugs slip through mutation testing. I've had to introduce new mutants to catch the bugs that slip through, and now the mutation tester will find them, but now it's too late for me. So hopefully it's going to work better for you. But there are situations clearly where mutation testing forces you to test all the behavior of your code. But what if you're missing behavior? Right? It can't save you. There's no way. But property-based testing might be able to save you if you can formulate the properties in a way that is easy for you to formulate the properties, and the property-based tester can sort of find that special case which is pretty hard, actually. So you might need property-based testing anyway, if it's really mission critical. If you're really mission critical, you might need formal verification, and nobody wants to hear that, because nobody does that, especially not in Python land, right? Another difference, because we talked about hypotheses before, is there's a big trade-off sort of between, or there's a big difference between mutation testing and property-based testing, and in that property-based testing is an exploration of an infinite space, right? You tell it, try this for 1,000 tries. And I'm like, okay, I passed the 1,000 tries, and then what? Are you done? Right? You have no idea. You can make it run for 10,000 years, and you might still have a bug, right? Because you need to specify the boundary conditions tight enough that it can find the special case. But maybe that's fairly hard. With mutation testing, you're going through a finite space because it's all the mutation points of your code. That's a fairly small space. So, like, you know when you're done with mutation testing, but with property-based testing, you actually don't know if you're done or not, which is a bit, I don't know. I get a bad feeling in my stomach, but you still kind of probably need it. So it's a bit annoying. Yeah. So is it worth it? Is the big question, right? Everybody's like, should I? Generally, well, sometimes so you should absolutely not use it for all code bases at all times. No, it's just not going to work because you're rerunning the entire test suite. If you have a test suite of 15 minutes, right, and your code base is 100,000 lines, that's just it's 50,000 times 15 minutes. There's just no way. It's not practical. But for foundational libraries that you use a lot in your code, like we have a bunch of them, I think it's absolutely worth it. And it's fairly okay speed-wise. It doesn't matter so much that it takes a lot of time. And if you have really critical code, that like access control or something that's really business critical, you can extract that and run only the tests for that specific code and just go through that. And that's fairly quick. So you can absolutely use that for that sort of scenario. So at Trioptima, we've run mutation testing on these are the public libraries that we run it on. We run it on some internal code. But so we have the try struct, token, declarative, query, form, table. I was going to do a lightning talk on declarative, but there's no time. You do need to redo it a bunch because you're going to change the code and you didn't redo the mutation testing, and now suddenly you have surviving mutants again, right? And we have 0 surviving mutants on try struct, token, and declarative, and we have surviving mutants on query, form, table because they're just bigger and it just takes a long time. So what I do is I have like maybe an hour before I need to go home, and I don't want to start a big ticket. I'll just do a little bit of mutation testing, add a few tests, and then commit them and sort of move the ball forward at all times. Yeah, and thanks for listening. So I can take questions, and I have like 6-7 minutes. I can absolutely continue doing the live demo if there are questions going. So I'm gonna do live demo and questions at the same time. Why not? There we go. Nope, not on. Then the button on it probably. Or just yell. Oh look, my mutations are gone. Show all.
It's on.
There we go.
Great talk. I was thinking about the mutations. Is there some sort of official list of mutations that you're using, or is it something you just came up with yourself?
I came up with them myself. So there are a few there are like two other big, two other known mutation testers called Cosmic Ray, who have more stars on GitHub than me, which is annoying. So please star on GitHub. I need to win the fight on the star front. And there's another one called mutPy, which was like a PhD student thesis, and it's gone dormant, and now it's sort of coming alive again. We're talking between us a little bit about standardizing on the names, so we could, for example, have whitelisting of whitelist this type of mutant, or just run this type of mutant preferentially, or something like that. It's sort of in the, well, we're starting to talk about it. Yeah. Yeah, so here we can see that.
Alexander.
No, I don't have time.
Yeah.
I'm gonna take
Hello.
questions.
So you mentioned Cosmic Ray.
Yeah.
That's the only mutation testing library I've used in Python, and would just like to hear like what's your top 3 features in your. I would like to test your library, and what's like the top 3 things that's better than Cosmic Ray?
Well, it used to be that you couldn't even install Cosmic Ray because you needed to install RabbitMQ, and I could never get RabbitMQ to install on my machine. So that was a pain. But they fixed that now, so you don't need to set up RabbitMQ with Celery and blah, 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 just to get started. So they fixed a lot of things, basically because I badgered them about it. So it's a lot better, but my UX is just way better. I mean, it is. You do, it's pip install mutmut.
You're missing the screen.
Okay, wait. Where am I? There we go. Pip install mutmut, and then mutmut run. That's it. And they're like, create a session, and start with the session, and a lot of crap. Really, you need to start, right? And you need to have feedback. So I'm gonna show what mutmut run looks like that. Boom, 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 boom. And it shows you that something is happening. You haven't hung, you're going, there's progress, nice emojis, so you know what's happening and why. The UX is extremely important. I rewrote the UX like 5 times, because I think that's one of the most important things you can have. And the command line is fairly nice, like you can do show all your mutants, you get a diff of all your mutants like that. Right? I think that's the biggest one.
Nice. I'll have to try it out. It looks nice. Yeah.
I think that's my number 1 and number 2 and number 3 good things, because it's just so much better. Yeah. Oh.
Any more questions? We've got time.
The live demo is not very good, but you see I can run it at least.
So, hi, thanks first for a great presentation. So I was thinking about instead of actually doing the mutations, could you put up some kind of watch point and then run your tests only once and see that you don't have to try out this mutation?
I'm not sure I understand the question.
So for example, with you had a foo bar with less than or equals.
Yeah.
So could you, when you run your tests, you could maybe try to record the values that you're testing and see that.
Yeah, you're talking about symbolic execution of tests. That's another whole field. But that's a very cool field, and there is no Python implementation. Sorry, but you can actually analyze symbolically the expression and run through it and check what the boundary conditions were. There are PhD sort of level things with that. There's no implementation that I know of, but it's a really, really interesting sort of field. Yeah.
Right, so you said you are caching the results of the mutation runs.
Yeah.
How do you How do you identify the cache that the code is what you are testing, what you were testing last time? If
Yeah,
you
so-
change the code, I mean.
So I have a little, my little cache database is an SQLite database with basically the entire source code in it. And just check if the line is changed. I just use the standard library difflib to get to compare what I have in the cache and sort of interleave it and see where it changed. It's really nice, by the way. Difflib is really cool. So I can figure out which lines have changed, and I can invalidate my cache. I'm pretty aggressive with invalidating lines from the cache. So like white spaces it's gonna invalidate the cache because I'm not sure.
Does it invalidate the cache partly or?
Yes, per line.
Okay.
Per line. And I keep the hash of the entire tests. So like I go through the entire test directory and do a hash of all the file contents. So if you change anything in the tests, I rerun the entire test suite for all the surviving mutants. I really would like to do something smarter, like running the tests, knowing which tests actually touch which code, and just running those tests instead of the entire test suite, right? But I've avoided it because I don't want to be bound to a specific test runner. Right now, I fire up the test runner and I just look at the exit code. So I support all test runners, and my competitors do not, because they have to have plugins for every test runner system. And if you have your own test runner system, you have to write the plugin, which is really annoying. So I just say, what's the command line to run your test? And I just go, which is very nice. The really big downside is I can't cut down the test time. And PyTest has a overhead of starting a process of like 700 milliseconds nowadays, which is really annoying if your test suite is 10 milliseconds, right? So if anyone has the time to benchmark and fix the performance of PyTest, please help. I'm fighting that fight, but I'm losing. It's quite annoying, because like 10 milliseconds tests should not take 710 milliseconds to execute, but that's how PyTest is nowadays.
Okay, so we thank Anders again for this very interesting demo and the talk. Yeah.
Thank you.